everyone. I am Alvin Bohol, and today I am going to discuss to you one of the topics in computer programming, and that is problem solving through Flowchart 1. Okay, so at the end of this lesson, we are expected to identify the characteristics of problem solving in computer programming. Number two, identify and describe the symbols in flowcharting. Number three, identify the conventions in pseudocodes. Number four, organize the day-to-day process using flowcharts and pseudocodes. And number five, deduce the benefits and shortcomings of flowcharts and pseudocodes. Okay, so to start our discussion, let us define what is problem solving. Okay, so problem solving is defined as the systematic approach in searching for a solution or set of solutions to a specific problem. Okay, in computer science, finding a solution to a specific problem is called algorithms. However, these two terms are not different, are different. I mean, why? Because problem solving is a general process of finding a solution to a specific problem, like defining the problem, breaking it down, and finding the most efficient ways to solve. However, algorithms is a specific process, a well-defined sequence of steps to solve the problem. So, problem solving is a general process, while algorithm is a specific process of finding a solution. Now, in computer programming, problem solving is the most essential skill that anyone venturing the field of computer programming needs. So, meaning to say, if you want to become a computer programmer, you need to possess this fundamental skill. Why? Because it basically will help you define whether a specific challenge is worth solving given a finite time. Now let us discuss the characteristics of problem solving and computer programming. So first is we have solvable. Okay, what does it mean? So in computer programming, a solvable problem, it refers to a problem or task for which there exists an algorithm that a computer can compute a solution in a finite amount of time. So this means that the problem can be broken down into a series of logical steps that a computer can follow to produce a result. Next is we have the goal-oriented. So what is goal-oriented? Well, in computer programming, this refers to solving problems or developing software with a specific outcome or goal-minded. Okay, so this approach is focused on defining clear objectives and then designing algorithms, systems, or programs that work toward achieving those goals. So, goal-oriented, it emphasizes results rather than just processes. And each step in the development process is guided by the end goal. Okay, so we have the goal. Next is we have a number three, we have verifiable. In computer programming, this refers to a program or algorithm whose correctness can be checked and confirmed, ensuring it meets the desired specifications or solves the problem accurately. Okay, so that is what verifiable mean. Now we have the number four, the quantifiable. So what does quantifiable mean? Well, in computer programming, a quantifiable problem or solution refers to one that can be measured or evaluated numerically, typically in terms of performance, resource usage, or output quality. So this allows programmers to assess how well a program or algorithms perform against certain criteria, such as complexity, space complexity, or the accuracy of its result. So this is what quantifiable mean. Okay. Next is we have doable in a finite step. Okay. So in computer science, a problem that is doable in finite steps refers to a problem that can be solved following a well-defined sequence of instructions that is guaranteed to complete after a limited number of steps. Okay, so this concept is essential because it ensures that the solution to a problem doesn't run indefinitely and reaches a conclusion in a reasonable amount of time. And lastly, we have doable and current technological limitations. Okay, so in computer programming, this refers to a problem or task that can be solved or executed using a computer power, hardware, software, and techniques available at the present time. Okay, so that is main doable and current technological limitations. So learning these characteristics of problem solving will help us to present our solution through the flowchart. And now we will discuss what is flowchart. So flowchart. Okay. So what is flowchart? So flowchart is a visual aid showing a sequence of actions or operations involved in computer programming. So this is an example of a flowchart. Okay, as you can see, there are symbols, arrows, and so this one is the start and this one is the end. So we will discuss this along with our discussion. Okay, so here. So this is an example of a flowchart. So it shows about a student leaving his home where we can assume that there is a heavy traffic when the time is past 7 a.m. Okay, so here, once he started to leave his home here, okay, he needs to check the time if the time is before 7 or 7 a.m. Okay, then if the time is before 7 a.m., he must still take a bus just to arrive to the school on time. So let us see, he needs to reach the school at 7:30 a.m. However, if the time is past 7 a.m., so he need to take the subway just to arrive at school on time. So knowing that past 7 a.m. has heavy bulk up of traffic, that taking a bus will not lead him to reach the school at or reach the school on time. So now let us discuss these symbols that we have seen here in the flowchart to fully understand what is flowchart. Okay? So symbols in flowchart. So in computer programming, flowcharts use a defined set of symbols to represent a specific action performed. Okay, so one of the symbol here is this one. So it is called a terminator. So a terminator indicates the beginning or the end of the process flow. So it is the beginning or end of the process. And next is we have this one. So this is called the process. Okay, so this is to indicate a specific action done. Next is we have the preparation symbol. So it is to prepare data or initialize something. Next is we have this one or data. A data symbol. So it is used to retrieve value from the user as input or present value to the users as an output. Next is we have a decision symbol. So this is used to identify which of the two possible paths will be taken based on the conditions set inside. Next is we have the on-page connectors. So it is used to connect two or more symbols belonging to the same page together to form a continuous process. Now we have this one, the off-page connectors. So off-page connectors is used to connect two or more symbols belonging to the different pages together to form a continuous process. So remember that on page, it is used to connect on the same page. However, the off-page is to connect different pages, okay, to form a continuous process. Now, let us identify this one. So let us identify the symbols used in the flowchart. Okay, so in every flowchart, we must begin and end with a terminal symbol to represent the start and end flow process. So this is the start symbol. So we start with the terminator symbol. Okay, so in this example, so we began this terminal symbol start to start the process. Then we use this arrow to show the next flow. Then the next flow, we use the data symbol. So it is used to retrieve. Okay, it is used to retrieve the input data. So if it is 7 a.m. or past a.m. Now the next symbol is the decision symbol. Okay, so this one, this is used to identify which of the two possible paths will meet the condition. So for example, if the time is before this one, before 7 a.m., he can still choose to ride a bus to reach the school. However, if the time is past 7 a.m., he needs to use a subway just to reach the school on time. Okay. Then after taking the decision, we use the symbol, this one, the process symbol. Okay, so which indicate a specific action to be done, which is riding either a bus or a subway. And lastly, we have the terminal symbol. Okay, so we use terminal symbol to end or terminate the flow. Okay, so these are the symbols used in this flow chart. Okay, now let us try to use an on-page and off-page connector. Okay, since our example here don't have an off-page and on-page connector. Okay, so this is an example of an on-page and off-page connector. So this one. So consider that this is one page and this is another page, or the second page and the first page. Now, okay, so we start with a terminator. So this one to leave home, then data, a data symbol to check time. Then then the next process is the decision. So if it is 7 a.m. or not, okay, so we need to identify which of these two paths will meet the condition. So for example, if our answer is no, so which means that it is past 7 a.m., then our next process is this one, a process symbol. Okay? Then, so assume that this entire page has no enough space to add another symbol. So this is the time to use an off-page connector. So just to connect this first page to the second page. So, okay. So to use this, we need to insert this symbol, okay? The symbol of on-page connector, and of course, we need to write a letter to point to the next flow, which is this one. Okay, this is the next flow. So we use the letter B to point here. Okay, and lastly, we use the terminal symbol to terminate the flow. Okay, if our answer or the decision here is past 7 a.m. However, if the answer is yes, so the first thing we need to do is, according to the process, we need to check the availability of the bus. So if there is available of the bus. So assuming that during this time there is a limited bus only. So if if the answer here in the decision is yes, then we need to to secure if there is an available bus. So if there is an available bus, so we take this yes. Okay, and another we use an off-page connector to connect this page to the second page to have a continuous process. Okay, this one. So we write a letter to point which is the next flow. Okay, which is the ride to ride a bus. And after this, we have a flow here to reach the school. So however, if the decision here, for example, there is no available bus, so what is your option? Okay, so the next process will, we are going to use this on-page connector. And of course, we have to write the A and find where is that on-page connector letter A. So as you can see, here is the on-page connector letter A. So this means that we are going to, so, or let us say the next flow is here. So since there is no available bus, so our best option to take so that we can arrive the school at school on time is to take the subway. Okay. Okay. After taking the subway, another off page that just to connect the first page to the second page to have a continuous process, then reach the school. Okay, so that is how to use an on-page and off-page connector in a flow chart. Okay, so I hope you learn with this discussion. Now let us discuss the standards and flowchart. So flowchart should always have two and only terminators. So namely, there's only two terminators, the start terminator and what? Okay, so the end terminator. So the start terminator always start the entire flow sequence. So it should always be the first symbol found at the topmost of all flowchart. So if flowchart sequence is multi-page, the start terminator is found at the, of course, first page. Then the end terminator is always ends the entire flowchart sequence. So it should always be the last symbol found at the bottom most of all flowchart. So if the flowchart is multi-paged, the terminator is found at, of course, the last page. Okay. Next is we have the decision symbol. So the decision symbols always have two possible scenarios, the yes and the no. So if the condition is not answerable by a yes or a no, the condition should be rephrased to adhere the standards regardless of the number of nested decision symbols to be made. So this is the case for the decision symbols since the computer can only process one condition at a time. Okay? So this is a decision symbol. Next is we have the flowchart symbol should always have one outgoing arrow. Okay? So since the arrow signifies that there is a progression of flow, it is a requirement that symbols should only have one arrow to other symbols. So we are limiting our thinking to single threaded flow. Hence, a symbol can only be succeeded by only one symbol. So The exception of this are the end terminator and the decision symbol. So in the enter terminator the marks the end of the flowchart. So therefore, there is no logical need for it to have an arrow. Okay, so meaning to say the end terminator should contain any outgoing arrow. Okay, and then the decision symbol has two possible scenarios. So therefore, there are always two and only two arrows in the decision symbol here. Okay, and next is so flowchart symbol can have any ongoing arrows. Okay, so since most symbols can start from any of the other symbols, it is logically accurate to allow any number of ongoing arrows. However, there is only one symbol that does not allow in any ongoing arrow. So this is the start terminator, of course. So that is the beginning of the flow. So to avoid confusion, where's the next flow from the start? So terminator start should have only one ongoing what? Okay, ongoing arrows. So the start terminator marks the start of the entire flowchart. So therefore, there is no logical reasoning to connect other symbols to the start terminator. So should there be a need to restart the interflow, the symbol should correct or connect to the symbol with an ongoing arrow from that start terminator. Okay, next we have flowcharts are written from top to bottom. Okay, so with the start terminator, this one, the next symbol should be placed below the start terminator. Okay, so this is the process symbol. Okay, and the next below previous symbol, there is some symbols beside a symbol, which is the case for the decision. This is, I know, this is not a decision, this is a process symbol. Decision, on-page connector, and off-page connector symbols. So, okay, this is the example of if a flowchart that has a top to bottom. Okay, it must start from the top to bottom. So it sh- it should not be the start here and our end should be here. Okay. Next is flowchart should not have any outgoing arrow pointed upwards. Okay, any outgoing arrow pointed upwards. So this is for creating a seamless flow process. So for example, flowchart supporting upward outgoing arrows determining the connection between the symbols will provide to be difficult. Hence, there is the need for this standard. So should there be a need to connect to other symbol found at the top of the sequence, you can use on-page and off-page connector symbols. Okay. Next is we have flowcharts should not have any overlapping arrows. So this is for emphasizing clarity. So having overlapping arrows creates ambiguity in the direction of the arrows intersecting and the respective symbols. Okay, so learning this flowchart is powerful that can enhance problem solving, communication, process improvement, and software development. By using flowcharts, we can create more efficient, effective, and well-documented processes. Okay, and now let us discuss a simplified way to describe a computer algorithm or program logic, which is a pseudocode. So what is pseudocodes? So pseudocodes are high-level description of the processes in computer programming. So they are not academic standard for expectant undergraduate students. However, There is a growing demand in the usage of pseudocodes not only in the academic sector but also the research sector. Okay, so this is an example of a pseudocodes. So pseudocodes are generally user-centric and no defined standards in writing them. Okay, so meaning to say writing pseudocodes are dependent to the programmer's choice. However, okay, there is an however. So however, for the ease for the codes to be written, we will set a convention in writing pseudocodes. Okay, so and here are the examples or a set of conventions in writing pseudocodes. Okay, so we have the declare. So the keyword is to declare. Its usage is to declare a variable and an array of. Okay, so a keyword, so description, a keyword to signify we are about to declare a variable b and an array a. So we have set as. So how to use this one. So it is a keyword to set variables, values to variables. Then we have append to keywords. So how to use this? So this like this one. So it is a keyword to insert string values at the end of a variable containing a string. Next is we have the f then, else if, then else, and keyword. So this is how to use this keyword. Okay, so it is a keyword to limit selected statements from being executed only when the specified condition was met. Next is we have the output. Okay. Next is we have the while do loop. Okay, so its usage. So this is how to use the while do loop. So while the condition one, if met, do this, then this one loop. So it is a keyword to limit selected statements from being executed repeatedly until the specified condition becomes false. Okay. Next is we have the output. So output, this is the usage on how to use output. It is a keyword to display a specific or a value of a variable to the user. Okay. Next, we have the input. So how to use this one. Okay, this is how to use the input. It is a keyword to accept any value from the user and save it to a variable. And lastly, we have the call. So usage is this one. Okay. And it is a keyword to call a user-defined or external function. So these are some examples of set of conventions in writing pseudocodes. Okay. Now looking back with our flowchart example before, so this is how pseudocodes is done. Okay, this one. Okay, so for you to understand pseudocodes better, let us use the sample, this sample flowchart. Okay, and remember that in the simple flowchart, the problem being solved is how to reach skull this one, okay, in the most efficient and travel-wise method. So following this flowchart, we will have this one, okay, as its pseudocodes equivalent, okay? So first is we wrote a call function to start the flow, okay? So to leave home. Then we wrote set time as, okay, we wrote the set keyword to set values to variables. And next we wrote this one, the if then else keyword. So if the time is this one before 7 a.m., then he can call ride bus. Else if not 7 a.m., then he can call this one. Okay, he can call ride subway. Okay, then and if then wrote call function to end the flow. So this is how pseudocode is done using this sample. So, and here ends our discussion. So, but before we end our discussion, let us summarize first what we have learned with our lesson. So, we have learned about the characteristics of problem solving in computer programming, and those are we have the solvable, the goal oriented, the verifiable, quantifiable, doable in finite steps, and doable in current technological limitations. Then also we are able to describe the different symbols in flowcharting, such as the terminal symbol, which refers to the beginning and end of the flowchart. We have the decision symbol or a conditional one, which is answerable with a yes or a no. Also, we have the data symbol for the input and output, a process symbol. Also, and we have also learned how to use an on-page and an off-page connector. So moreover, we have learned how to use flowcharts and pseudocodes and able to discuss the benefits and shortcomings of flowcharts and pseudocodes, and that with flowchart we visually represent processes and algorithms aiding a problem solving, decision making, and process improvement. However, flowchart can be time-consuming and may not suitable for dynamic and iterative processes due to its limited complexity. I mean, limited flexibility. And on the other hand, we learn pseudocode simplifies our description of algorithms and program logic, breaking down complex problem into smaller and understandable steps. However, unlike flowcharting, pseudocodes lack in visual presentations that may cause potential ambiguity. So, and here ends our discussion in Computer Programming 1, Problem Solving through Flowchart. I hope you learned something. Thank you for listening.